I'm going to move on to the next part of the build, which is the amplifier, driver, and power amplifier. A quick note before starting, for pretty much the most part I've used sort of genuine DigiKey Mouser components for parts. The OPA2674, which is at the heart of the driver, and the RD15HVF1, which are the sort of the power MOSFETs. I obtained both of those from eBay, so we'll see how they stack up. Obviously, if they don't work too well, I'll go back and source some originals. Anyway, just picking up from where we left off. So where we left off in the last video is I'd had put a 47 ohm resistor across here, and I was basically probing here. So this is where we're going to start from. What I'll do is I'll install T4, and then I'll install the entirety of this section here, which consists of this pair of dual OPA2674 wideband high current op-amps. And I'll include a link to the datasheet below. The circuit used is very similar to this circuit down here, which I found in the, let me just pan down and zoom into that so you can see a bit greater detail. So that circuit actually came from page 17 of the datasheet. And it basically gives the gain of this single stage is equal to 2 times RF divided by RG plus 1. So RF is this pair here, RG is this, and then if we look up at the diagram, let me just pan up to that. So you can see here it's structured a little differently, but essentially this is RF and this is RG. So you can see in this first stage we've got this times 2, which is 660 divided by this, which is 3, plus 1, which is 4. So we should see a gain of 4 here. And then in this section, these two are the same. So that's 470 times 2 divided by 470. So that's 2 plus 1 gives a gain of 3 for this section. Gain of 4 here, gain of 3 here. So let's just move down now to the power amplifier. So zooming in on that section. So this consists of this pair of RD15HVF1s in a push-pull configuration. And the bias for this flows through this MOSFET here. So here's the bias voltage, the bias source here. It flows through this P-type MOSFET here when TX neg over to the right here is pulled to ground. So TX neg is pulled to ground on transmit. So the bias itself is controlled by this pair of multi-turn trim pots right here, R33 and R35. And note also in this design, we have negative feedback coming through this turn of transformer T1. So we've got this on both sides, we've got this 220 ohm resistor and this capacitor, and this is what provides the negative feedback to the following stage. So just panning over slightly, you can see on the right hand side here, T5 is the final output transformer, and then it goes off to the low pass filters. So basically what I do to test that is I wouldn't include the low pass filters. I'll probably just 50 ohm terminate this and then test it without the low pass filters to start with. Just in terms of the order that I'll be building and testing this in, so let's just pan up to the driver stage. So I'll build right up to this pair of resistors here, these 4.7 ohm resistors here. And then what I'll do is, at least as far as I can see this, the input impedance of this stage is sort of governed by these 24.9 ohm resistors. So what I'll do is I'll terminate this with 25 ohm resistors, and then I'll be able to test this stage. And I should see, as I inject a single sideband signal here, I should see an amplified version of that signal on the other side. So once that is done, let me just sort of pan down to the relevant section. So once that's done, I'm going to build up the bias circuitry here. So all this is filtering up to here. There's that P-type MOSFET. So I'll be able to sort of put all this together. I should click on transmit, and I should see, I should be able to see a bias voltage on the other side of these diodes. And then finally, just moving over to the power amplifier section, I'll get all that together, put all this together, and then, like I said, I'll be able to sort of test right here with 50 ohm terminated, and we should see the final signal. What I'm going to do is, as I said, let me get that driver section, all this section together, and we'll come back. Now, just to sort of show where that actually goes on the board. I've got the board up the wrong way here, so bear with me. So that pair of OPA2674, this all goes here. So I'll populate all this stuff here, and then I should be able to test the output of that. Okay, so it's just a quick build check. So what I've put together is all this circuitry here. I've put together the resistor divider here, which sets basically the center tap of this transformer T4 at mid rail, which is 12 volts. Xen is installed, and then there's a few parts of the op-amp network that are on this side of the board. So, for example, this element here. So what I'll do is I'll go to the board and check a few voltages. So I'll check to make sure we're getting 12 volts here, and then I'll check to make sure we're getting the mid-rail bias right here on the transformer. Should be around about 6 volts. So let's go over to the board and check that. Okay, so here's the components on the board. So there's T4, so we should be able to probe the midpoint there. I'll actually probe right there. That's an easier point to probe. Should get 6 volts there. Here's that 12 volt Xena right here. So this is the end I'll be checking. Should be 12 volts here. The other thing to pay attention to is these two components here and here are the tantalums, and they're polarized. So if this is the positive end for C112, and this is the positive end for C110. So positive end has the stripe on it. So let me check voltages there and be right back. It's going to be a little tough to do behind camera. Let me apply voltage, and it's turning on normally. So so let me probe around here. So let's first probe. Oh God, got to do this behind the camera. So let's probe right here. Should get 12 volts right here. And there we go, you can see 11.8-ish volts there. And then the other spot is over here, so I should get half of that over here. And there we go, 5.9-ish volts. So that confirms both of those voltages are correct. What I'll do now is move on to the other side of the board and get those op-amps installed. Okay, so the op-amps and the surrounding resistors and capacitors are installed. Note the orientation of the op-amps. You've got the dot and the dot and the dot and the dot. So no other components really to speak of. So let me just pan out a bit and I'll show you the test setup. I got a couple of 47 ohm resistors at the other side of these 4.7 ohm resistors right here. So that's on C133 to ground and C125 to ground. So what I'll be doing is I'll be probing at here and at here, and we'll have a look at the output on the oscilloscope. Okay, so there's my test setup on those probing. There's two 47 ohm resistors. Let's have a look at the track on the oscilloscope, and I'll just hit transmit. Here we go. And that's exactly what we should see. Basically, phase and anti-phase signals out of either side of that. And we've got peak to peak of around 4.2 volts. So if you'll recall from the last stage, I think it was around about 470 millivolts. So now that is using 47 ohm resistors. So and I do believe the actual input impedance is around about 25 ohms. So that voltage will go down a bit, but that's a healthy signal there on both of those. You can see they're 180 degrees apart. So that's exactly what we want to have as input into the following stage, which is the MOSFETs. So what I'm going to do is I'll move on to that now, Just for giggles though, let's increase, let's go up to 14 megahertz and retransmit. And you can see there again, the voltage is a bit dropped, but got that nice phase and antiphase signal at the output there. Just finally, just to do the test, let's change the time base out to up around 500 microseconds. And there you can see 13.9993, so I'm injecting a 700 hertz tone at 14 megahertz, so that's exactly what we should expect to see there. And just finally, for a bit of fun, we'll do the two-tone test again, so I'll do 700 hertz and 1900 hertz. And there we have that, that nice two-tone signal. A little bit of distortion at the crossover point there, that's kind of interesting. But obviously, the further down the stages in the amplifier we go, the more distortion you are going to get. So go over what's coming up next. So basically, I've built up to these two resistors here. The next stage I'm going to work on is the bias circuitry for the MOSFET. So what I'll do is I'll build up all this here, and then I should be able to see 5 volts here or thereabout. I'm not actually quite sure what the bias voltage is there. I think it's 5 volts, but I should be able to see a 5 volt signal here on transmit. So I'll build up to here, make sure I get the 5 volts there, and then I'll build this part here, and then I should be able to confirm after that part that I'm actually getting that 5 volt bias on top of the signal at the gate of the MOSFET. So first this, and then I will obviously save the MOSFET to a subsequent part of the video. Okay, so that's the first part of the bias switching circuit installed right here. I did have a bit of trouble with this diode. I think I've got the wrong size diode here, but it wasn't quite enough. I had to do a bit of solder bridging there. But here's that P-type MOSFET, and basically this connection right here is the drain of the MOSFET. So on transmit, I should be able to see the voltage that's at here on the other side of that 10 ohm resistor. It's actually about 9 volts, but I should see close to 0 volts when not transmitting, and 9 volts when it is transmitting. So let's get the multimeter on there and check it out. Okay, so it's currently not transmitting. Got to get my hands out of the way there so we can test it. And you can see there it's about 0.2 of a volt roughly. So let me just enable transmit over here. And then we'll test at the drain again, getting my arms out of the way here. Alright, so there we go. And you can see that's now at 9 volts. So that's confirmed that that P-type MOSFET is turning off and on correctly. So we'll move on to the next part of the build, which is I've got to install a couple of pots that go here and here, and there's some filtering caps and a couple of diodes, and so I'll get those installed and come back. Okay, so that's the rest of the bias circuitry installed. The only polarized components are these two diodes, D8 and D7, and you can't really see it here, but the stripe is on this side for D7 and on the opposite side for D8. On the other side of the board, we have those two trim pots, and let me just bring them into focus there. And you can see, confusingly, they have their, it's counterclockwise to increase the bias voltage on this one, and clockwise to increase the bias voltage on this one. So anyway, what I'll do is, this is actually the gate, this the bottom pin here, and the bottom pin here is the gate on those two. So what I'll do is I'll get a multimeter on those two, and we'll see the bias voltages and make sure we can adjust the bias voltages by turning the multi-turn trim pots. Anyway, I'll get that set up and come back. Okay, so it's all set up. It's in receive mode, so it should be able to should be close to 0 volts on the gate of the both of those MOSFETs, and indeed it is. So let me turn on transmit now, and we should now see a bias voltage. I've set it to around about a volt. So there's a volt on Q5 and about a volt on Q6 too. Okay, so I've turned both these pots in the direction. So this one I've turned 2 turns counterclockwise. This one I've turned 2 turns clockwise. We should see increased gate voltages on both of those. So now it's up to around about 1.6, and the other one's around about 1.6. So that just confirms that these two trim pots are acting as expected. So what I'll do now is I'll just move over to the oscilloscope, and we'll confirm that that bias voltage is actually being applied to an incoming signal. Okay, so for a final test on the bias circuitry, let me actually go into transmit mode with an injected 700 Hertz tone at 14 megahertz on lower sideband. So there you can see, I've got the scope in DC mode. There you can see that DC offset kicking in there of about 1.6 volts. Peak-to-peak signal of around about 3.5 volts. So everything looking good. Let me just probe, make sure the other gate is the same, and indeed it is. So that confirms all the bias circuitry's done. This video is actually running a bit long, so I don't think I'm going to make it to installing the final MOSFETs and the toroids associated with that. Probably deserves a video in itself. So what I might do is wrap the video at this point. We've got all the bias circuitry installed, and that sets it up for installing the finals in the next video. So I hope you enjoyed this video.